Okay, so you just finished your area unit and had your test. Hopefully that went well. And so our final unit of the year is on volume. So now we're doing three-dimensional objects, and the first one we're going to talk about today is prisms. So what is a prism and how do we find its volume, basically? Well, before we talk about a prism, a solid formed by polygons that enclose a space is called a polyhedron. Cross out the figures that do not represent a polyhedron. So go ahead and pause and do that. Okay, so you should have only crossed out two things, the cylinder and the smiley face. Because why is a cylinder not a polyhedron? Well, because those are circles, and circles are not polygons for its bases. So therefore, that doesn't work there. And this, obviously, it's not three-dimensional. It's just a smiley face. It's not a polygon, so that's not a polyhedron. The others work fine. Okay, recall a hexagon is a polygon with how many sides? So hopefully you're saying 6. We've done a lot with hexagons. So what do you think a hexahedron is? Circle the one polyhedron from above that is a hexahedron. So that's going to be a 6-sided polyhedron. 6-sided polyhedron, or 6 faces. So which one of these has 6 faces? Well, obviously not this one. This one has a base, which is 1, and then it has 5 faces around the edge, so it's only 5. So top, bottom, right, left, front, back. So this is our hexahedron. This only has 1, 2, 3, 4 faces. This has 1, 2, 3, 4, 5, 6, 7 faces. This is a lot more, so this is our one hexahedron. Has 6 sides or 6 faces that you could touch. So the only exception to this nomenclature is what you might have called a quadrahedron. So meaning we could have a septahedron or we could have an octahedron, but you cannot have a quadrahedron like a quadrilateral. Instead, for a 4-sided figure, it would be a tetrahedron. So I just told you, sorry, how many faces does a tetrahedron have? That's 4. So which one of these is a tetrahedron from above? So that would be this one here. It has 4 faces to it. So it has this bottom one, right? That's 1. It has, and then it has 3 sides. This is 2, this is 3, and then of course, the one right here in front, let me get a different color, is 4. Okay, I know it's hard to visualize, but try to do that. It's got 3 faces coming up from the base and then the bottom base as well. So it's 4 different sides. Label the face, edge, and vertex of a polyhedron on the right. So specifically, this is a hexahedron. So what is the face? The face is this right here, right? I keep calling them sides, but actually that's called a face. The flat, smooth part that you can see that we can put different colors. The edge, right here, this is the edge. What we used to call the side of a polygon, this is now the edge of a polyhedron. So the vertex is still pretty much the same. Where 2 edges meet, that is called your vertex. Okay, so there we have it. Different parts of our polyhedron, our face, edge, vertex. Recall, a regular polygon is a polygon with all sides and angles that are equal, or you could say all sides and angles congruent. Right, so we've still been doing a lot with regular polygons in like your last unit, finding the area. We usually did that with regular polygons when we were doing a pentagon or hexagon or etc. So what do you think a regular polyhedron is? So a regular polyhedron is going to be something that has equal sides, right? These sides are going to be the same, these angles are going to be the same, and the face areas are going to be the same. So each side, or each face, is going to be the same. Each edge is going to be the same length. So if it says, which of the figures above is a regular polyhedron? Well, we're just guessing because I didn't put any measurements. So again, I'm going to go with this one here. I'm going to say if this is a square, then all these sides are congruent to each other, and here, right? So we have, that's probably a regular polyhedron. Do we have another one? Well, this one could be as well if we had an equilateral triangle. If everything was an equilateral triangle, which you can't really tell, it doesn't look like that, but if it was, then that would also be a regular polyhedron. So it's when all of the sides look like the other side. They're all identical to each other. Okay, now let's get more specific here to a prism. A prism is a type of polyhedron with two parallel congruent bases. Two parallel, they must be parallel to each other, the bases. The faces that are not bases are called lateral faces. What is the shape of a lateral face? So look at this over here. This is a prism. What are my bases? My bases are the two parts that are parallel to each other. Well, hopefully you can see here that this pentagon in front and this pentagon in back are actually my bases. And typically you might see that flipped the other way, where this is sitting down here, right, and then this one's up here in the sky. Oops. And I'm connecting it, it's going up and down like that. Sorry, it's a terrible picture. But yeah, usually I have this one in front and this one in back, so it's a little bit harder to tell, right? But hopefully you can see that these two are parallel to each other. Right, so this is your other one. Oops, that's parallel. So what is the shape of a lateral face? Well, your lateral face is going to connect, like this side, we're going to connect those to each other. So what shape did that make? So maybe it doesn't look perfect, but what shape are these making? Right, so what shape are those making? Well, those should be making rectangles in this case, but sometimes they could also be making parallelograms. So you have two choices, rectangles or parallelograms. But this, even though it doesn't look like that because I kind of drew it off, these are all rectangles in this case. Right, these are all rectangles. So they're rectangles. If these are rectangles, these lateral faces, then that means this distance right here, the length of the side of a lateral face, is also known as the height or the altitude of your prism. So this specifically is a right prism. We have oblique prisms, we have right prisms. Right prisms are going to be, right, they're going to be, sorry, I'm trying to draw a right prism. Standing straight up and down, they meet at right angles, but if I drew an oblique prism, then I no longer, then it's slanted. Sorry. So everything's slanted, so my height is no longer going to be this edge length, it's going to be whatever the distance is from this top base to the bottom base. Look through the picture for better diagrams. Sorry, I'm going kind of fast, so I'm not making the best diagrams in the world. Okay, how many of the 8 figures above are prisms? So how many of the 8 figures above are prisms? So look at these. So again, what is a prism? A prism is a polyhedron with 2 parallel congruent bases. 2 parallel congruent bases. So could this have 2 parallel congruent bases? Yeah, this looks like a plus sign, the front and back. Those are 2 parallel congruent bases, so this could be a prism. This one, no. This one, yes. This one, no. No, because it's circular, and this one, yes. So we have here, here, and here. If you're not sure about that, ask me in class and we can go over it more. Label a base, a lateral face, and a lateral edge. Label a base, a lateral face, and a lateral edge. So this is a base right here in this picture, right? This blue pentagon is our base. Lateral face, well, the lateral face is going to be the rectangle, the red part. This is our lateral face. And a lateral edge, well, that specifically is just going to be any of these pieces here, a lateral edge, which basically your lateral edge is your altitude or your height in this case. So then it says, yeah, what is the prism's altitude? Sorry, I keep already answering that. So the altitude is this length of the lateral edge if it's a right prism, or it's the height of the figure if it was standing up like this. If I laid it down, right, then that square would be in front, the square would be in back and connected, but still that's going to be your height if you put this pentagon on the bottom and you're standing upright. So the altitude is the height as well. Okay, moving on. Let's change our page. Okay, so I'm moving on. The question that I've tried to answer before, but I don't feel like it's necessarily going very well. This is a situation where I wish I was in class in front of you talking and explaining a little more clearly. But again, ask questions if you're not sure. But here, what is the difference between a right prism? Here's a right prism, here's an oblique prism. Think Leaning Tower of Pisa, remember it's kind of tilting to its side, right? So here is the oblique prism. This is still on the ground, this is on the ground, but it's leaning over. So the height of this is no longer the length of the lateral edge. It's going to be the distance from here to here, which is going to be different from when it leans to the side. Or sorry, from when it's straight up and down. So just know with an oblique prism, your height is this distance here, which is going to make a right angle with your bases. Okay, moving on. How would you find the surface area? So we're going to talk about surface area and volume today. How would you find the surface area of a prism? You must add the lateral area to the base area in order to get the total area. Lateral area is all of your rectangular pieces, right? So this blue part is our lateral area. Your base area is your triangle up here and your triangle down here. Those are clearly the bases, right? So we need to add all those pieces together. So, sorry, what's missing here? These are right angles. These are right triangles right here. So the first thing I have to do is see if I have all the information I need, or am I missing something that I need to calculate. So right here, I believe I'm missing something. I know this is 3, I know this is 4, but I have to find this. You can either find that by using the Pythagorean theorem, or you could know that this was a special case or a Pythagorean triple where that hypotenuse is going to be 5. Right, so now I know all those pieces. So if I want to find the area of my triangular bases, actually I didn't even need that. Well, I did actually. But this is 4 times 3, so that's 4 times 3 divided by 2. But then there's 2 of the triangles, so those basically cancel and we get a 12. And then my lateral faces, I have one that's 7 times 4, right? I have one that's 7 times 3. And I have one that's, well, we had to find that to get this lateral face, that's 5 times 7. 7 times 5. Well, they all have a 7 in common here, so what could we have done? We could have actually factored out the 7 and just done the 4 plus 3 plus 5, which is the perimeter of the triangle. So down here it says, how do you find the lateral area? Well, the lateral area is just this, again, it's the rectangles only going around. So you would take the perimeter of the shape, whatever it is, in this case it was a triangle, and multiply it by the height of that figure, right, a lateral edge. So yeah, 7 times 8, 12, so then we could have added that all together. So my bases were 12, this is 84, so it looks like altogether this is 96 centimeters squared. 96 centimeters squared. What if you want to calculate the volume of the prism? Well, that's different. That's 3-dimensional. So remember your volume, if it's 3-dimensional, that's everything that you would fill this up. If we poured water in it or sand into it, that's how much volume would be covered. So that's your 3-dimensional space. So how would you do that? The base is 2-dimensional, and then you must multiply the base times the height. So first, find the area of this red triangle down here. So the area of the triangle we said was 4 times 3 divided by 2. And then we multiply that by the height. So this is the volume, which is 12 divided by 2, which is 6. 6 times 7 is 42, so that's 42 centimeters cubed this time. We must do units cubed because it's 3-dimensional. And this is the area of volume here. Go ahead and answer these questions at the bottom, and then I'll do another video to give you the answers.